In previous video and tutorial, I showed how we can produce the lattice plot using the x, y, and z coordinate of the atoms and how we can map this magnetization in the x direction on this point. So we will quickly produce this plot because we have completely explained this before in the previous tutorial. So we see that when we map this information on the x, y, z coordinate of this atom, we can see the magnetic moment along the x direction with different intensities. So another way we can show the difference in the magnetic moment of these atoms is using an arrow with different lengths or different intensities instead of using these colors. So to do so, if we want to have arrows instead of colors, we need to make some changes in our data. So for arrow, we know that we always have a starting point and an end point. So we have a tail and we have a tip. So if we suppose that these points are the tail of our arrow, to create the tip, we need to have these intensities. So I'm going to repeat these two columns. Let me first delete them. And then I'm going to copy this column and paste them here. And for the Z column, because I'm going to have the intensities involved, I will write a function here, and this function would be, you see there is fx equal to, so whatever you write here, that will be calculated in your column. So I will have the C column plus G column, and this will calculate these endpoints, which is the location of each point, the z coordinate of each point, plus the intensity of the magnetic point. So by this way, we are creating the arrows, and we are giving the information to the software that these are the starting point of our arrows and these are the end point of our arrows. So we can show our 3D lattice plot and the intensity of magnetic moment with arrows rather than having a simple circle or spheres with different colors. So to see how it works, we are going to produce the scatter lattice plot again. And I will double click on the image. And then I will go to 3D vector and enable this in a 3D vector. Then I can go to this endpoint. So this endpoint, the vector type is xyz. End of x would be the same. I don't change the end of x. So what is end of x? End of x, I haven't produced a new column. I have just copied the x column and put that in the d column. So end of x would be d. For end of y, again, I have copied the same column. So end of y would be e. And end of z is the column I have created, which is the f column, and it's the sum total of c plus g. So I will choose f column as the endpoint of the z column. And you can also have different scales, different lengths. And you can choose the color. You can choose type of line. It can be a dashed line. It can be a short dash or short dot or whatever you want. So I will stay with the solid line, and you can have any color. So I will choose black. And let's see what happens. If more changes are required, then we will apply that. So you see that there are some black colors appears on the image, but you cannot see that completely. You cannot see these arrows. So to see these arrows, we have to remove these circles. So this is a trick we need to do here. So I will double click again on the image. And it's kind of slow because this is a 3D plot. And I will go to the symbol. So when you go to the symbol, you can use this trick. So you have created this arrow, which are kind of covered by these circles. So you can change the size into 0 and then apply that. And when you change the size into 0, you see that those symbols, those spheres disappear. And you can see only the arrows that you have. So if you want to see clearly the arrow, their direction, and the difference in their length or intensity, you can simply zoom in or zoom out. And you see if the thickness of your arrow is high, then you cannot see the arrow clearly. So let's change the thickness. Again, double click on the image, and I will go to this original tab, and then I will go to the 3D vector. And here you see that the width is a little bit high. So I will go to the 0.2 and then apply that and click on OK. Now let's zoom in. Now you can see that magnetic moment of your MTJ-MST is represented by arrows, and since one of your electrodes is antiferromagnetic and the other one is ferromagnetic, you have the direction of all your spins downward in your left electrode, and the direction of your spin on the right electrode is up. And the reason that some of them are shorter, some of them are longer, is the difference in their intensities. And these intensities are the magnetization along the x-axis. So you can simply show your lattice plot in origin using your x, y, z coordinates, and you can map your mx, my, mz on the coordinates and on the atoms. And you can also show your lattice plot with arrows. And so if I zoom on the molecule, you see that the molecule direction, the spin of the molecule is same as your front electrode. So it has produced a ferromagnetic coupling with your electrode on the left, and it has an antiferromagnetic coupling with the electrode on the right. Okay, thank you. Hope you have enjoyed this tutorial. Let's zoom out. And that's it.